All right, our next type of visual to make with some probability problems, especially when you are given conditional probabilities. If you are told a conditional probability, that is a clue to use a tree diagram. And oftentimes what happens, the breakdown in probability, when I start losing students, it's because you don't know when to do what scenario. So if I told you go ahead and make a tree diagram, you might be able to finish the problem, but you got to learn when to do them yourself. Okay, so if you are told a conditional probability, it's probably a good idea to maybe make a tree diagram. A tree diagram helps us think through conditional probabilities, showing sequences of events as paths that look like branches of a tree. Making a tree diagram for situations with conditional probabilities is consistent with our Make a Picture mantra. This figure is a nice example of a tree diagram and shows how we multiply the probabilities of the branches together. All the final outcomes are disjoint and must add up to 1. We can add the final probabilities to find probabilities of compound events. All right, so this problem, I believe it's in your textbook somewhere if you want to go look at where the problem is actually written out. But what's happening here is you've got the percent of, I think these were teenagers, so the percent of teenagers that participate in binge drinking at 44%, which I know none of you do this, the percent of teenagers that participate in moderate drinking at 37%, and the percent of teenagers that abstain or do not drink at all at 19%. For you guys, this number is much higher, at least I hope it is. All right, next, these are all conditional distributions or probabilities. And what this is the percent of binge drinkers who were involved in an alcohol-related accident. That's this number right here. The percent of binge drinkers, not all people, not all teenagers, the percent of the binge drinkers who were involved in an alcohol accident, 17%. Now the complement of that was binge drinkers who were not, 83. This number was probably not told to me. I just know that those need to add to 1. All the kind of sets of the branches, like these 3 in this row or column here, these 3 numbers add to 1. These add to 1, these add to 1, and these add to 1. What this is the 9% of moderate drinkers were involved in an alcohol-related accident. So therefore 91 were not. And 0% of the people who don't drink at all were involved in an accident or were drivers in an alcohol-related accident, which makes sense if they don't drink. If they got in an accident, it wouldn't be alcohol-related because they don't drink. Now, what you do with a tree diagram is once you have all this filled in, you multiply across. And when you do the multiplications, you're doing the probability of A times the probability of B given A is what you're doing. When you do that multiplication, you are finding the probability of A and B. Okay, this is the formula for the probability of A and B. So when we multiply 0.44 times 0.17, we get 0.075. What you have here is the probability of them being a binge drinker and getting in an accident, alcohol-related accident. And this number is the probability of them being a binge drinker and not being an alcohol-related accident. And the probability of them being a moderate drinker and getting in an alcohol-related accident, the probability of them being a moderate drinker and not. And the probability that they don't drink, probability of not drinking and being in an alcohol-related accident. And this one is the probability of not drinking and not being in an alcohol-related accident. These are all of the possible scenarios that could occur. You have to be in one of these groups. If you are a teenager, you have to be in one of these 2 groups. So if you add up all these numbers, you get 1. Meaning every person is in here somewhere. Every teenager, everybody we're talking about is in here somewhere. They're either they binge, they drink moderately, or they don't drink. And if they do binge, they either were or were not involved in an accident. If they do drink moderately, they either were or were not involved in an accident. And if they don't drink at all, they either were or were involved in an alcohol-related accident. Tree diagrams can be complicated, and I know some of you are probably going, wait a minute, what? Like you're a little confused. They take practice. You need to make sure you practice these. They are in the practice problems. Using the tree diagram presented, what is the probability that a randomly selected student who has had an alcohol-related car accident will be a binge drinker? What is the probability that a randomly selected student who has had an alcohol-related car accident, you've got to pick up that is a condition. What is the probability of a student will be a binge drinker? So we want to know the probability of binge drinker. But you are being told they were in an alcohol-related accident. That is a conditional probability. The formula is binge and accident out of just the accidents. Binge and accidents right here. That's in our tree. That's why the trees are so important, that number. And then the accident groups, a little bit harder to find. They show up in 3 places. They're here, here, and here. Those are all our accident people. So my denominator needs to be the sum of those groups. 0.075 plus 0.033 plus 0. Notice that this number is within this set. That is always the case. The top number will always be a part of the denominator. If not, we got an issue going on there. So I can go to my calculator quickly and type that in. I don't need to add 0. Notice I got parentheses around that denominator, 0.69.